part and the video part.
Hello everyone, thank you so much for viewing into today's session. I'm Rohit Iyer, your student mentor from Upgrad, and today we have with us Mr. Bikash, who would be taking the session on BFSI. And without wasting any further time, it's over to you, Mr. Bikash.
Yeah. Hi Rohit, and hi everybody on the other side. I feel myself I was on the other side of the screen 4 or 5 years back, and if possible, if such sessions were available back then, it would have been really helpful for us. And I really appreciate the effort Upgrade and folks at TapChief collaborated to put this session together. And I find it's very motivating. Why I use the term motivating is because this makes us feel more, not only from the student side, also from the industry side, that people are learning proper things, which can help us eventually collaborate or tie up, and also encourage students who can maybe possibly start their own idea, or maybe a startup or something. So that's actually a very bold step Upgrade and TapChief has taken. And today I feel I'm actually kind of very much excited that I would be able to share my experience, 4 or 5 years of experience into this field of machine learning. And earlier we used to collectively call it as business intelligence and analytics, and nowadays we call it with a more fancier name as data science, machine learning. But nevertheless, it's all about trying to find new meaningful insights out of the huge data volume that we produce and consume every day. Great. So welcome to this session, and please do share your questions. And if I have the answers right now, I will give it to you. If in case, again, my knowledge could be limited at some areas. So if I happen to not know some answers, I'm being very upfront that I'll definitely find those answers for you, and share them via Rohit, who is now conducting this, or if there is any other possible means, but you'll definitely get your answers. I hope in last 4 or 5 years I have learned enough to answer those questions, but there could be areas where I might not know at all about a question, but I'll definitely get back to you with those answers. Yeah. So before this session was recorded, we were discussing about two very common questions that are being asked regarding any data science or machine learning interviews. And one of those questions was this: what is machine learning, and how does actually a machine learn? Yeah. Now, we used to get several answers to this question, and majority of the time, I will just quote three examples, three common answers that we used to get for these two questions. And I would upfrontly tell you that those questions were not appropriate for the question, and the question seems to be a little bit tricky, just because the interviewer has to actually explain what he's trying to find out using these two questions. Okay, first of all, it is a general thing. What is machine learning? Yeah, the students gave a lot of answers. Machine learning can be broken down into three pieces broadly: supervised learning, unsupervised learning, and reinforcement learning, right? Again, that is not a correct answer. Second thing is, people do come up with a lot of algorithm. Machine learning is like getting your data fed into a linear regression, and the computer automatically figures out what the parameters are, and how the line would fit in the curve, and so on. And if the linear regression does not fit well in the curve, then they would maybe switch to another algorithm, and so on. So all these answers are good enough, but they are not appropriate when we actually ask what is machine learning and how does the machine learn. So let me explain what it actually means. So when we ask about how does a machine learn, do not start giving an answer related to the algorithms or related to the problems that you have tried to solve, or related to any algorithms that your team has built, which is different from the readily available algorithms, right? What we are trying to understand from you is, when you talk about a machine is learning, what actually it means how do you tell a machine that this is my data and you should learn from it? Yeah. And that is a very basic question that majority of the people just ignore, because they think the end of the game is to learn about the algorithms and to be able to apply those algorithms. So why I am putting this question as the very first slide, although we are supposed to discuss about the banking and financial service, is because this question is very common throughout any domain you will be working on in the future. So uh, where to find, I will give you a certain basic answer to this question, but if you want to also understand the technicalities and the code underneath how a machine actually learns, then you might follow this book, and trust me, just the first two chapter of this book is enough. It's not more than 50 pages of reading. It can be done in a day, and once you have cleared and this guy Sebastian Rashka has explained this concept very well and very thoroughly. So once you get an understanding of this, your understanding of other algorithms will become very easy, because every algorithm are based on this particular basic algorithm, which was, I think, invented back in 1950s and 1960s. Okay. Now, coming back, so this was just a general introduction. I just wanted to clear out at the very beginning of this session that, just before appearing for any interviews, just make sure that both of these questions you have a general understanding. So basically, what is machine learning? Is basically we are trying to find a pattern, right? Based on the data that we have already collected, and that pattern should be good enough to any future data that we will receive or we will collect. We are not trying to memorize any pattern. This is again one common answer that we used to get. A machine is trying to memorize the combinations of all the variables with the output. No, we are not. That is not what is the main purpose of the machine learning. Machine learning is all about finding a general pattern. It can be close enough. Of course, we try to reduce our error as much as possible, but it more or less, it means that we're trying to find a general pattern so that we can, on basis on that, we can take future decisions. Okay, now moving on, especially in the banking and financial services, this is one area. You work for any banking or financial organization, if you happen to work closely with the data science team and the machine learning team, you will come across this problem set. And as we are progressing, the hackers and the miscreants are also progressing, and maybe they are progressing even faster, right? So this is one problem statement that you will always get, how to detect fraud that is happening. Sometimes the fraud would be quite obvious. Sometimes it may not be that apparent. So how do we define a fraud? So depending on different products, I'll take an example of online banking, or I would take an example of say you are swiping your debit card somewhere, right? So there could be a security breach somewhere, either in the online banking. There could be a bot or something in the browser which is keeping a track of your password that you have typed in your keyboard, or the customer ID that you have entered in the online banking system. And as a result, what would happen? You'll compromise your account details with that bot. Now, before launching any such open-ended and in a scale, so when we talk about banking, we have like millions of customers, right? And it is of utmost our responsibility as a fraud analytics team and people who are in the technical side of this. We have to figure out n number of ways to protect the customer, because if even if one customer gets hacked or gets into trouble because of any of the loopholes, it's a actually not only financial loss, but it also is a reputation loss. And because of reputation loss and financial banks and financial services might lose lot of businesses, and that's not a good thing for us. So how do you define a fraud? Of course, we keep processing millions and millions of records of data. I would put it that way. I would not go into petabyte and exabyte of data. So we have millions and millions of customer transaction details and their browsing history, how they have, where did they click on our browser, on our apps, and we try to figure out, has there been any pattern which is not known to us? Yeah, because we know what features our app provides, we know what features our online banking services provides. Anything which seems uncommon, we really take it very seriously. And that's where, first of all, even jumping onto the any algorithms, that's why I have written here, no algorithm to be used. What I meant by that is we don't start looking into patterns just from an algorithm perspective. Algorithm comes in a much later stage. What we try to do first of all is define a problem. Okay, what does one of the example could be is, sometimes when when we process our browsing experiences of our customer on our browser, we sometimes check whether, there has been something like this, spider.bot.text. So this is one kind of, spider agent used by some hackers to behave like a human. Yeah, and they try to crawl into the browser and try to snap away customer details. And we keep monitoring for this kind of activities, whether do we see any such pattern of details in our logs. Yeah, so that is one example. Of course, once you work in this industry, you will come to know about lot many other bugs and other bots which tries to snap away customer details from the while people are typing, even they have not completed entering their texts. So that is one. Second thing is, once we know, suppose this is one of the pattern that we found, which is very uncommon because we have not installed any services which use this kind of names or this kind of functionalities. What to do? So then we go for, a heavy data processing. We try to see how many times they have occurred. Is there a pattern? Like what time of the day? Is it for a particular region? Is it particular time? Is it particular type of customers? Is it particular, is it only for with the senior citizen customers who are facing during their browsing it has happened? So we try to figure out all those patterns, and sometimes here we kind of use unsupervised learning, right? You must have learned it during your course. This is one example, because when we are trying to find patterns, if we don't know what we are looking for, that is a good candidate for unsupervised learning. Yeah, and once so we typically try to use clustering methods, and using those clustering methods we try to find out what are the unseen groups, unseen patterns that our log throws up, and based on that our next decision comes in picture. So we also talk very much with the business analyst team, the implementation team, the operations team. In case they are familiar with any of these agents that has been added and but may not have circulated with other team. Quite possibly there are new we as a analyst team might not because of, and it commonly happens, there could have been a communication gap, there could have been a depend 10 items might have been shared and then only 9 have been picked up. So there will be areas where such things might skip. But then at banking industry we not only do double or triple checks, we do n number of checks before releasing any solutions to protect our customers. We do heavy testings on that. So how is this a data science problem? Yes, because as a human, it's impossible to look into, say we have, I'm just quoting an example, say we have 10 million customers, right? And if you look into their browsing history, each customer probably have created 10,000 records of data for us. They might have clicked on a different link, they might have waited on an account statement, they might have done n number of things. And for us to humanly finding a pattern, again, coming to the same basic definition, machine learning definition is, it's basically trying to find a pattern. Sometimes we know what the pattern is, sometimes we may not know. So suppose if a customer has a lot of declines happening because of certain things, we know the pattern, and that's when we probably can use supervised learning. But in cases of fraud detections, we may not even know what a fraud would look like. That's where we probably we are going to use unsupervised learning. Moving on to the next problem statement. Rohit, if there is any question in between, kindly let me know. I can see I haven't got any questions so far here, but just do let me know if somebody is willing to ask a question on something.
Yeah, sure. I'll just post it to you on the group chat, and then you can get it answered.
Absolutely great. Okay, great.
Okay.
So you can still see my screen, yeah?
Yes, I can.
Okay, great. Okay, so next interesting thing, fraud was a bit boring. I can totally understand, but you know what? Data science on the top looks very, as they call it, the sexiest job in 21st century. But underneath, you are basically doing a lot of data cleaning, data massaging. What I mean by cleaning is, for example, say, I'll just you add here. When we say, suppose we want to track and send SMSs to our customers. So if you see, somebody might write their phone number like this while filling out, their form. 806 would be the area code, remaining is number. Somebody might write it like this. By the way, that was my number earlier. It's no longer in use. So this is another phone number. You probably will also get something, people writing it this way, so this is just a 3 example, but there can be hundreds of other ways people do enter their phone numbers. Although our front end team makes sure that while collecting the data, we try to collect as clean data as possible. So nowadays, pretty much every banking companies and financial companies, while taking customer data, they have made a standard pattern that they automatically fill it in. For say in India, they will automatically come with the postal code already entered for India, and then they will put something as 3 digits, XXX, and they will have an hyphen XXXX, and then XXX. So this is simpler. People easily can follow that pattern and correct it. But then the problem actually comes when we look into the typically the Indian postal addresses. It would say, backside of backside of some medical store. Yeah, and based on this. It's very challenging to do data processing. So in many cases, we try to clean up the data. We'll try to use remove this kind of statements. And what we do for that is we have a huge address code book. We call it address code book. And we have created a lot of stopping words. We call it like backside of medical store, or some landmark. Yeah, people, we have seen people put it beside a cloth shop. People put it that as a landmark because for humans it's very easy to locate the cloth shop and the postal address. But for computers, it's very challenging for us to keep that as an input to our computers. So instead, we just stick to, for example, in addresses in Pune, we have very some, at least some standardizations done. So we have like some survey numbers, and then the society name, and then we have the flat number. Yeah. So still, it's a very standard way of getting the customer addresses. Just saying, in banking and financial services, we do not we use it for our analysis, but we don't disclose customer details, not their phone number, not their gender, not their name, not their account IDs, or any such details in any of our solutions. It doesn't come up, it doesn't show up. So we may take extra precaution to make sure that none of the customer details are visible anywhere, not in our app, not in our analytics solution. Okay, and this is one very standard mandates we have to follow. There are government regulations on that. So in banking and financial services, one has to be very particular about this thing. That you can, of course, for analytics, for safeguarding our customers, we do have to use their details. Also, we have to inform our customers that we are using their details for our internal purposes, for our protection systems, and we do get some consent from them as well. Okay, now coming to the idea of new product or services launch, this is very interesting area, because this is where the main promotion of machine learning and data science started, making it more lucrative. Whenever we talk about new product or services, so you might wonder, in banking and financial industries, product typically resembles more like an hardware product or software product. But in banking, we have products like insurance, mortgage, loan, etc. You also have products like loyalty programs, cashback, and all those things. There also we term it as a product. Services could be, like sharing, transferring money from one bank to another bank. Like for example, in HDFC, we can transfer money from one HDFC account to another banking account. It could be with Axis Bank. Typically, I'm taking examples from India only. HDFC to Axis Bank or Punjab National Bank, and these are the services that a bank nowadays commonly provides across. All banks do provide these facilities mostly. Now, coming to the idea of how can you use data science and machine learning, to be very specific, to come up with new product and service launch. So let me share one of my recent experiences. That we have launched a loyalty program a couple of months back, and the acceptance rate was quite good. But what we still saw was that out of 10 million customers, only 50% people have opted for that loyalty program. And we were wondering if data science or machine learning can help us somewhere to figure out why the acceptance rate is so low, and if possible, can our solution, can our data also give us some insight to figure out how that can be improved, and more and more customers could be onboarded onto that kind of programs. So what happened was, when we saw into the loyalty program, we saw that people who have mortgages, who have loans, are the only customers who were preferring these loyalty programs. Because obvious reason was, because you have taken a home loan, or we call it mortgage, or you have taken another study loan or car loan. So basically you are paying money to the bank as a premium, also as an interest. Yeah. So if there is a way we can get money from the bank by doing certain activity, like you are doing some x number of transactions per day or per month, you get certain benefits from those loyalty programs, right? Typically that's how a program works. So we were interested to find if there exists any pattern, then we can tap on it. Yeah. So that's where our data science methods comes into picture. So what we did was very simple. We used again, typically whenever there is a classification kind of problem, so here we convert it into a classification problem, that whether a customer is interested or not. So basically, in your classification problem, you can call it as a binary problem, yes or no. So we used a standard logistic regression here. So now I can relate, once I told you about the pattern, once I know that if I have to relate it to a ready-made solution, so we have used a standard logistic regression. We did try with decision trees for classification problems and other stuff, but trust me, majority of the solutions that you will be designing in an industry does use all these basic mathematical solutions like linear regressions and logistic regressions. The reason is, even though decision tree is still much more understood by humans, logistic regression is much more easier compared to decision trees and other stuff, because end of the day, the business decision, people who are taking the business decision are humans, and they have to logically understand that how and why this process is working, why and not this process is not working. Because if as a human we don't understand the process, we will be not sure to take a decision. Yeah. So that is why it is always a good idea to start with a very simple model, which is in this case of whenever we are talking about new products, we try to find patterns of yes and no, or what would be the probability of a customer opting for a loyalty program, or if this is a new product, whether people will like it or not. I'm emphasizing on these options, like it or not, because they are all into binary classification, and logistic regression does do a really good job. So if something is beyond a probability, so we can set a probability and acceptance of what we call it as acceptance probability, which means if it is less than zero point 0.6, then it's a yes. If it is more than zero point 0.6, then it's a no. It could be vice versa as well. Okay, so what I meant to say is whenever we are launching a new product, we first study the current existing customers who have already taken that program or have been using that product. Now, that is not the only thing that we do. What we also do is, in comparison of that product, we also have some natural language processing algorithms written. What it does is basically does some complaints analysis. So it most of there will be a lot of customers, or there will be a lot of products which will have a lot of complaints, and then there will be a lot of products and a lot of services which people really love, right? So in many of these products, many of these services, whenever we see a lot of complaints have occurred, we do take them seriously, because that also gives us a room to improve. And that's again very interesting, natural language processing toolkit provides us. One is called TF-IDF. You can just read it. It basically gives us how many times a particular complaint word has occurred across all customers and across all products. So basically, if there is a something like as a balance transfer failed or account locked, something. So that gives us an idea that their majority of the customer are facing a same problem. So this is something which our operations team and decision making team uh, should immediately look into this and solve this problem, because of that we are losing a lot of loyalty programs, loyalty program customers, and so on. So basically we try to balance so many things at the same time. So in a real banking and financial services, for data analysis, it is not just one area that you will be looking at as a data science professional. You have to look for root cause. One thing you might have learned during your upgrade training session is something called as null hypothesis, right? What does that mean in this particular loyalty program product? Is that, somebody, a business person who have much more domain experience, comes and says that, if we can give, say, 800 rupees of loyalty program per month, a customer will get 800 rupees if that person does 8 transactions in a month. Okay, that is a random hypothesis. He thinks or she thinks that, if people are made to do 8 transactions per month, bank will earn enough to give them 800 rupees of cash back or some loyalty benefits. But then that is a hypothesis. Now, in order to prove whether that hypothesis is true or false, then we go for a deeper data analysis, and then we either we go for customer feedback, we do complaints analysis, and try to see whether can we justify this hypothesis, or is it like we need, say, 10 transaction and not 8 transactions to, to be making enough money by the bank to give them a loyalty of 800 rupees. Also, we have to see whether 800 is still keeps the bank profit, because at the end of the day the bank has to be more profitable. So we just see whether it is 8 transaction or 10 transaction, or whether we should reduce the amount in the loyalty program, whether it should be 800 rupees. I'm just making up numbers. Whether it should be 800 rupees or it should be 700 rupees. Now, machine learning and data science does help, and as I told you, logistic regressions take into consideration a lot of variables here. Here, the variables could be the loan amount, it could be the per month salary of that person, it could be whether that person is married or not, it could be whether that person has other loans or not. So all these factors comes into picture whenever we are looking into the either providing a new service or whether we are launching a new product. Second, on a very similar line, comes about something known as a recommendation system. Even in our recommendation system, we see, suppose we know a gentleman, he makes X amount of rupees in a month, have a car loan, and have a family of, his spouse and a child, and he have opted for the loyalty program. Now, there will be hundreds of similar, very similar profile who have taken the loyalty programs, and also very similar profile people who did not opt for a loyalty program. Now, if that, and so there comes again several hypotheses. One of the hypotheses is that particular gentleman already have an account with another bank, and they're already giving him sufficient loyalty rewards, cashbacks, and other benefits that my bank is not offering him. That could be one hypothesis. Now, if that is one situation, then it becomes very challenging to get the data, because of course we cannot intrude into somebody's privacy to find out which other banks they are using. But then we keep diving into other, whether that person have over the time reduced the number of transactions. If that person have reduced number of transactions from the bank, that means it could also mean that person is not happy with the services the bank is providing. And then we also check whether that person have raised any complaints which has not been addressed. So if you see, before even recommending a product, we are now looking at the complaints that have not been addressed. So targeting one particular problem statement has, moved us in a direction which is very more crucial to solve, whether certain problems, very basic problems, where they are in his online banking or with his ATM card or app, the mobile banking app, have any such challenges. That is why he is not happy with the services. He has raised several complaints but have not been addressed, and so on. So if you see, it will always happen that in many of the data science project, you started with one hypothesis, but you are now solving a totally a different problem, and which could be even more important. Okay, so these are few of my experiences working on launching new product. Churn analysis is again the very same thing as I just explained, that uh, um, you have some customers whose transaction has gone down over the last several weeks or months, whereas prior to that, that person was very active with the banking. He was digitally active, and his transaction amounts were good. But right now, because of some reason or the other, the transaction of that person, he or she has reduced using our ATM card at other shops. He or she has reduced, you're doing more transactions with our banks and stuff. As a result, what we do, we try to evaluate that person, whether and we try to predict basically whether that person is planning to leave the bank, right, or go to another bank. I'm sorry. um, so that is where we have a separate analysis and analytics team on this, where we try to figure out, where we try to predict whether a particular customer is planning to leave or not. Again, how do we do this? It's very similar to defining new product and launch. What we do, we study our existing customers who have already left. We see their behavior, we see their browsing, we see their clicks, we see their transaction behavior, and so on. And we see if other people are also doing similar things. Then we try to, offer them some benefits. We try to talk to those customers and figure out. That's why we have relationship managers at banks, where they frequently keep calling customers just to figure out if there anything else we can help them out. And if more and more number of customers have given a very similar feedback, then we try to come up with new products and new services. So churn analysis is very common in banking and financial services, because there are many people join the bank because they were giving some offer, right? Some banks recently I have seen, they offer a VR, a virtual reality glasses, which can connect with your phone, and people just opened an account. And but people really did not have any intention to, stay with that bank. They just joined because they were offering VR, and after 6 months they all quit. A majority of them quit because the benefit of the VR is over now. So all these decisions and all these things comes into picture, and several of these channel analyses are influenced by competition. So for example, if your bank is providing a saving interest rate of X%, suppose, so you save your money with a bank, and your bank is offering X% of interest per year, whereas your competitor is providing X.5. A point 0.5 in banking industry is a huge number when you talk about millions of rupees. So that could be one area where a lot of customers leave the bank. Loyalty programs, again, some banks give you a cashback on a minimum expenditure of say 1,500 rupees, in first 3 days or 4 days while you got your credit card or something. What happens is the competitor bank is providing you for if you do only 1,000 rupees of transaction. So why would people stay with you, right? That could be. So these are small scale customers. Banks are not always too much worried about that. Banks are always much more worried about people who are doing transactions in millions and millions of dollars and rupees, right? Because that's how banks get funded, one way or the other. Similarly, in churn analysis, well, there are a lot of student accounts where you have minimum balance account and stuff. And if they don't see a benefit over the long run, if the process is hectic, if it takes a lot of manual process involved, where you have to submit documents and this and that, customers might choose to go to other banks. So all these data are getting collected, the behaviors and other stuff. Based on that, we try to figure out, again, churn analysis may not be a supervised learning, because we may not know the exact input and output relationship. So again, we fall back into unsupervised learning. In banking and financial industry, you'll see a lot of unsupervised learning things happening. Okay. Rohit, so far so good. Any particular question? Yeah, I see one question from Raju Kumar. Mm, okay. For others, I'll just read it out. Raju asks, is this fraud detection an automated process where you deploy a ML model, or is it a manual process? Yeah. Excuse me. Okay. In banking and financial services, the entire thing is not entirely automated, although because detection, the something a computer might have detected as a fraud may not turn out to be a fraud. So in all our models, there are in a regular intervals there are human involvement there. So, for example, every week we try to see logs and reports and see whatever our algorithm has termed as spam or fraud. So we try to reclassify them and say that, okay, this is a new product or new services, a new agent that has been added into our algorithms or our banking servers. So this is totally fine, and then we classify it into our input algorithm, and it revises from the next time. It does consider those as a non-fraud thing. So yes, entirely, it is not an automated process. Does that answer your question, Raju? Yeah. Yeah. So moving on, if Raju, if you have any further query on that one, please post it in the YouTube session. So moving on, recommendation system. We have already just spoken about it. Um, recommendation system will be kind of like a daily bread and butter for you once you join this kind of data science clubs. Okay, where you have to find new ways of figuring out how to reach out to customers, what offers to be made. Also, recommender system helps very much when we are deciding whether we should give a credit card to a student or not, whether we should give a credit card to a person who already have lot of mortgage and home loans. So you might have probably noticed that, for a student the credit card limits are lower. The reason being because eventually bank has to collect that money, right? And if a student, also depends whether the student is in his or her first year of studies or second year of studies or third year of, because you are more third year of studies, people are more likely to get a job compared to a first year or second year. So also the limit of their credit card might go up and down. So if you're a third year student, your credit card limit might be upper compared to a first year student who has offered asked for a credit card. Similarly, a person who has no loans, no mortgages, his or her credit card limit would be higher. And if a person already has mortgage, car loan, and home loan, student loan, and other stuff, his or her credit card limit will be lesser, and it will be more difficult to increase that limit. So that is a very common area. Recommended system comes into picture, and even when you apply for a home loan or credit, there are teams who uses recommendation system to see whether are you credit worthy or not. They will check your transactions, they will see how much balance are maintained throughout a year or last 2 years. We also see what is your salary income. We also see how lavishly you spend, because that is important for the bank, because if you spend too lavishly, it is risky for the bank to collect that money. So we also track, depending on your transactions, and also your credit score, that if you have previously, if you have taken any loan, how timely your payments were, has there been any default or not. So you can say there are like 20 or 30 variables which goes as an input, and then there is a output again, yes or no, whether should I give you a loan or not. Yeah. So recommendation system is a very common and interesting field, and I would highly recommend all our learners that do learn how to build one, because recommendation system is not only useful in e-commerce, where in websites like Flipkart or Amazon, you see people who have bought this item has also bought this product. Exactly, in banking industry, we have something like whether should we recommend you this product or not, or should we give you credit or not. So recommendation system is used possibly that way. Yeah. So these are the three or four broad areas where most of your energy will be focused on while working in banking and financial services in terms of data science and machine learning. But there could be also other areas. I typically work around these four things, and um, you might find this very interesting. There are a lot of examples, a lot of study materials online freely available. You should definitely study and refer to this, or you can also reach out to your professors at Upgrade, who can help you build a step-by-step model, a simplistic one rather, to see how recommendation system works. If you have not built it already, you should definitely do that. If you have not written any fraud detection, you should. New product and services launch, depending on your existing customer data, you should be able to come up with new product. So again, a very important thing in the field of banking and financial services is we do not entirely rely on our codes and algorithms. Okay. Once an algorithm has given us some recommendation, we again thoroughly test it manually. We take enterprise surveys just to make sure that whatever our algorithm has suggested us, does it actually make sense. It is very important. If it is not human tested, we typically don't implement those solutions. The reason being, machines, the recommendation system, the new product and services, a machine is as good as the data that we fed in. Yeah. If we give, as you might have already heard this phrase, garbage in, garbage out. If we give garbage data to the, or sample biased data to the algorithm, it will give us a sample biased output. If we say that if we have given an input that to our new product algorithm, and if we have given all the people who have taken mortgage are willing to take a car loan, say all our customers are in that category, who have already have a home loan, and they are now willing to take a car loan, our algorithm will say yes, everybody is interested in whoever has a home loan, by default they will take a car loan, which can be a totally disastrous solution, because we gave a highly biased input to the algorithm. So it gave us a highly biased output to us, and you can see it from a overfitting and ideas. So coming back to the, I think I'm almost at the end of my conversation, but this is again very important. Some of you might think, we keep generating new data science problem every day, and we keep working on data science problem. That is not always true. Okay. We I think our team generates around 10 ideas a day, that which we can solve using data science. Then we take it to our data science directors and business team, and eventually it turns out that those can be solved by simple if else conditions, right? Instead of spending hundreds of hours to design a data science, because there will be many things which our domain experience already knows. So we also keep rejecting a lot of ML projects, because our main intention is not to just work on data science and machine learning. Rather, we use data science and machine learning to help us in our ideas, and it's other way around. Data science doesn't give us actual answers. Data science does give us a conformity, that what we think is actually correct or not, and whether our data also talks on similar line or not. So there will be many a times what will happen is we started a machine learning project, but then we turned out that there are much more simpler way of finding information out of that data instead of using data science and machine learning. So as a result, we stop wasting our hundreds of hours into this, and we rather go with the traditional method. We just data visualize and get some idea. Okay. So, and common example would be, you don't need data science to figure out that the people will buy more umbrellas during rainy season, right? They will not buy umbrellas during winters. Uh, so it's very obvious. You don't need machine learning for that kind of problem. So many a times you will, as a data science professional, you will be asked to first evaluate whether it is actually a data science problem or machine learning problem or not, and can this really help us or not. So with that, I have covered all the experiences that I had in this area. Rohit, would you like to take over and share any more questions you have found, or how do you want to proceed further? Only last thing that I have it here is these are the few technical fancy thing that you must know before working or applying for a data science role in banking and financial services, uh, which I think I will share it with Rohit and he can distribute it to you all. Yeah, these are the very common things that we regularly use in our day-to-day tasks. Again, all this has to have a meaningful human logical reason behind it. Okay, I keep telling human logical reason because there has been a hype that data science does it all for us, which is not true. Okay. Yeah, Rohit.
Yep. So currently we don't have any more questions.
Okay.
As far as I can see, if there are any questions, then I'll just mail it across to you so
That
that
would
you can
that
answer
should
it,
be
and then
yeah.
I'll share it along with the PPT as well.
That should be totally fine. I'll share this PPT with you after this call, so that
Okay.
you can give it to your give to the learners. And yes, please do come back with your questions, because that way it also will help me get you. There could be interesting questions, problems that we can actually put effort to solve. There could be many areas, right? So I would really encourage them. Yeah.
Okay. So that sounds great. And we'll just conclude the session right away.
Mm-hmm.
Okay. So yeah, like I said, if there are any questions, I'll be sure to post it.
Sure. And I would also encourage the learners, probably I was too fast, too slow, although I didn't get much more comments on the live session in YouTube. But please do share your feedbacks to me. Yeah. I'm sorry that I had a cough today, so my voice could be a little shaky this morning. So just share your feedbacks, and if you need more examples, more technical way of looking into things, just let me know.
Okay, sure. So, yep, that's just about it for today. I'll just conclude the session.
Sure, right. Yeah. And thanks all the learners. Thank you very much for joining the session today.
So thank you so much, guys, for viewing into today's sessions. In case you guys have any questions, please feel free to reach out to me on either WhatsApp. We have the WhatsApp group. You can send across your mails. I'll get them answered by Mr. Bikash. And I'll be sure to share the PPT with you once I get it. Okay. So
Yeah.
have a great weekend. Take care.
Yeah. Thanks, everybody. Have a lovely weekend. And thanks to you, Rohit, for coordinating this. Yeah. It was really superb. Yeah. Great learning experience for me as well. Yeah.
Thank you so much. Yeah. Bye-bye.
Yeah. Yeah. Bye.